Section 2.1 talks about the derivative and rate of change. So, the tangent line, we derived that last time. The tangent line to a curve y equal f of x at the point A, f of A is the line through the point P with the slope of the tangent would be the limit as x approaches A of f of x minus f of A over x minus A. This is definition 1. You need to know that a bit because in the homework they ask use definition 1, use definition 2. On the test I don't specify. I'll give you the actual definition if I want you to use it. I wouldn't call it 1 though. And difference quotient formula that I derived for you last section. We did that problem, we did a limit, and it turns out to be this, if you remember correctly. And if you don't remember correctly, it's right there. Beauty of technology. When we talked about what it means to have, where did it go? Right there. When we talked about if you take a limit as h approaches 0, this becomes the slope of the tangent, velocity. It has many names. So, two definitions. Now, this is the key. We're going to use this more than this, way more than that. But for now, we want to practice what they say in the book, and this has its own benefits, but this works on anything. This has a couple of exceptions. So on page 113, if I look at problem number 4, it says, find the slope of the tangent to the curve. Use an equation 1, use an equation 2. Here's a point, and here's the definition. In case you missed it, a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. Now, by the way, I forget to mention, if I replace x by a, that will be f of a minus f of a minus a. And if I replace h by 0, that will be f of a minus f of a. So this is the special case of the shortcut, provided we're dealing with these functions of polynomials, radicals, rationals, and trig where they're defined. We want to look at this problem, and they say find the slope of the tangent at the given line using definition 1. Definition 1 talks about limit as x approaches a, and notice the point a f of a, and there it is. They threw 1 in there. 1 minus 1 cubed is 0, so that's a. In this case, by definition 1, the slope of the tangent is going to be the limit as x approaches 1 of f of x minus f of 1 over x minus 1, and the definition is right there. All what you do, replace a by 1. I'm cluttering this. Clean it up. So, if we start with that problem, well, we know how to find the limit. If you throw the limit x equal 1 in, you're going to get a 0. There we go. And minus, what's f of 1? Either I use this and plug 1 in, or I use the 0 because I already know it's a 0. And at any stage I replace x by 1, guess what? I'll get 0 over 0. So the top, I could factor an x out. That would be 1 minus x squared over x minus 1. That's the limit as x approaches 1. I could factor the top into the difference of squares. And what happens when I cancel opposites? I pick a negative 1. So that would be a negative. Throw the 1 in into 1 plus 1, which is 2. That limit is a negative 2. Got it. And that's basically it. Using definition 2. Definition 2 says find the limit as, and there's definition 2 right there. And also I want to unclutter that, has too much on it. If I take the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h, that is the limit as h approaches 0. F of 1 plus h would be 1 plus h minus 1 plus h cubed minus f of 1, I know that's a 0 in this case, over h. And at any stage I replace h by 0, guess what I'll get? 0 over 0. This is 1 plus 3 times h plus 3h squared plus h cubed. This is the limit as h approaches 0 all over h of 1 plus h minus 1 minus 3h minus 3h squared minus h cubed. That would be the limit as h approaches 0. You notice the ones cancel out, and I can combine. That would be negative 2h minus 3h squared minus h cubed over h. The limit as h approaches 0. Now on the exam, I'd like you to work the same way I'm working, downwards always down. And anytime you want to split the page, make sure you put an arrow, factor an h out. And I notice those cancel out, and once they cancel out, guess what? I'll use the shortcut again. I'll throw 0 in and I'll get a negative 2. So it doesn't matter how you do this. Now, it might seem that this is a better option. For this problem, yes, and that's why you want to get really things going and practice those on the homework to figure out which is which. Find an equation for the tangent line. I have a point of 1, 0, and I have a slope of negative 2. Y minus y1 equal m into x minus x1. There you go. Do you have to clean it up? You could if you want, you don't have to. The back of the book might have y equal negative 2x plus 1. You could leave it in point slope form. You don't need to write it in slope intercept form. So we're going to practice another problem. And here they're saying at A, in general, find the slope of the tangent. Well, it's up to you what you want to use, which equation, 1 or 2. I'm going to use equation 2. I'm going to take the limit as h approaches 0 of f of x plus a plus h minus f of a all over h. So again, equation 1 has a couple of drawbacks. This works on anything, and that's for the next sections. F of a plus h is 1 over the square root of a plus h. F of a is 1 over radical a over h. This is a complex fraction. From now on, I'm going to assume you keep up with the work. That's the LCD. So if I figure out what each of those are missing, multiply this by radical a top and bottom, multiply this by square root of a plus h top and bottom, and multiply this by radical a plus h. And we explained in the previous sections why you ignore the denominator and just read the top. That would be radical a minus the square root of a plus h times radical a times square root of a plus h. And if I throw h equals 0 in there, I'll get 0 over 0. What do we do with radicals? I'm glad you asked all of these questions last time, because now you know. You multiply by the conjugate. You're going to multiply this by the square root of a plus the square root of a plus h top and bottom. And that's going to become, the top will be the first squared minus, make sure to use parentheses, the second squared over h into square root of a into the square root of a plus h times square root of a plus square root of a plus h. Now, the first definition might be simpler. I choose to do this all the time. It's up to you. A derivative is defined in terms of this definition, not the other definition. So, a couple of sections from now, you're going to have no choice but to use this, so might as well. Those cancel out. And do you notice that I can cancel this h with that h? And if I throw 0 in, I'll get the square root of a. A 0 in there, that's the square root of a. A 0 in there, I'll get the square root of a plus the square root of a. And that will be negative 1 over. This is simply a, and this is twice radical a. I don't mind you leaving the answer like that. That's fine. And then they say, hey, find an equation of the tangent line. If x equal 1, again, you need to really get this out of the way. If you replace x equal 1 right there, that's how they get the point. Sometimes they say at x equal 1, sometimes they give you the point. Y minus y1 equal m, what would be m in this case, into x minus x1. And for this point, y minus y1 equal m into x minus x1. So the story never changes. In algebra, we never gave you the slope of the line. You always have to find it. This told us the slope at any given point A. In this case, if A equal 1, what would this be at A equal 1? That would be negative 1 over, if I put a 1 there and 1 there, isn't that a 2? And there it is, done with that problem, right? And here, if I replace x by 4, a by 4, I'm looking at negative 1 over 4 times twice, square root of 4 is 2, that is 16. There's my answer for this part, and there's my answer for this part. Maybe I should have did that here. Negative 1 over 1 times twice square root of 1, which is negative 1/2. So now they talk about what does it mean. Oh, hey, what happened to that one? Let's fix it. Velocity. The velocity or instantaneous velocity at time equal t. We do know that this is the slope of the tangent, in case you missed it. We do know that this is the slope of the tangent, and we do know this is the slope of the tangent. Definition of a derivative at a point A, and do you notice how they define it? The definition of a derivative at point A. So 1 or 2 will do. If they don't specify, it's your choice. The tangent line to y equal f of x at a f of a is the line through a f of a with a slope which is the derivative at a. Well, let's see. I wanted to do something like number 17 on your homework, but I couldn't find any problems in the book, so I copied number 17, but I altered it. This is prime. The irony of that. So I'm going to take that green point at negative. This is a curve at the green point. If you draw a tangent line, do we agree that the line looks something like that? If I take at 1/2, negative 1/2, there's negative 1/2, about right there. The tangent, we talked about tangent last time. This looks like an ugly tangent. There we go, much nicer. Not really. And I don't want to use this because it's very hard to do. To get it to look tangent, it's kind of annoying. But there it is. I could fix that. There we go. And if I go for the pink at 1, and at 3 where I have blue, and let me just get this one out of the way. At negative 1, it's a bit tilted to the right, just a bit. So on the test, I'll make sure that those are not very close. Directions, I'm mimicking number 17, directions for the function whose graph is given. Arrange the numbers in increasing order from smallest to largest. If I look at those, we know that the slope of this tangent line is 0. We know the slope of this tangent is positive. We know the slope of this tangent is negative, and we know the slope of this tangent is negative. Well, if we're going to start with the smallest one, wouldn't this be the smallest right there? So wouldn't you say start with g prime of negative 1/2? Right? Then, this is negative as well, but it's bigger than that, so that goes next. Then, a 0, definitely. And it seems the biggest is g of 3. G prime of 3, which is the slope of the tangent. Do not mix the slope of the tangent with the point itself. Right? Just be careful with that. And let me see now. Would I have time to finish this?